Okay, I'd like to get started, please. Okay, so John, you need to put that away. Number 49, okay? On page 147. You're given that y squared equals x cubed, and they want you to find d2y by dx squared in terms of x and y. Okay? So the first thing you're going to do is differentiate once. What do you get on the left-hand side? What do you get on the left? Nice, good job. And on the right? Nice. Isolate dy by dx. Well, there are two ways of doing this. Let's just do it the old-fashioned way, where you isolate that. Is everybody okay on that? Differentiate one more time. So on the left, you'll get d2y by dx squared. And then you're going to use a quotient rule. So this guy is going to become 4y squared, right? And you're going to keep 2y and differentiate 3x squared, 6x. Minus, you're going to keep 3x squared and differentiate 2y. Y prime, let's just write it as dy by dx. Okay? All right, you with me on this? Is everybody okay on this thing? Then all you need to do is take dy by dx out of here and shove it in here. So S, what was the issue?
The issue was that I had, and then I went on CalChat and it said when you have 3x squared for y prime.
You don't have 3x squared for y prime. You get 3x squared over 2y.
Yeah, I know, I wasn't finished. But like it says it has that, and then multiply it by xy.
I need to talk to a boyfriend, okay? I want to see how he's being treated. I want to see how he's being treated. Okay, S, let's go. S.
Can I talk?
Yeah. Oh. Okay, yes, boss. Yes, ma'am. Yes, ma'am. Yes. Go, go, girl, go.
3x squared over 2y times xy over xy. And I don't know where the xy over xy came from.
3x squared over 2y times xy over xy.
Yeah. No, xy over xy.
Over that?
No, I mean xy, parentheses xy, over parentheses xy. No,
Yeah.
like that. No, like, xy over x times y, yeah.
Over x times y?
X times y over x times y.
Well, x times y over x times y is just 1.
Well, I don't know why they did that though.
Let's see, why did they do that?
The ending answer becomes 3x over 2y.
Well, I mean, let's go ahead and do it the old-fashioned way. Let's see where it goes, okay? So this is, well, we'll go there in a minute. Shh, Kartik, shut up. Okay? 12xy minus 6x squared. And in place of dy by dx, you're going to write 3x squared over 2y over 4y squared. Is everybody okay on this? Am I doing this right? You guys got this okay? And then your common denominator upstairs is going to be, what's it going to be upstairs? 2y, so this becomes 24 xy squared minus 18x to the 4th over 4y squared. This is clearly not their answer, is that what you're saying?
Yeah.
How did I? Well, 6x times 2y is 12xy. Sorry? This is 2y here, right? So that becomes your common denominator. So you cross multiply. 2y times 12xy. Yeah, because you're finding the common denominator. Like, how do you do 3 minus 1/5? Don't you find the common denominator as 5 and go like that? Same thing. So shall we take a look at their answer and see if we can understand what they ended up doing? There is no 10, that's 18. That's 18. So 2.5 is 147. Karthik, dare you listen to what I'm trying to say to you, dude? You guys have issues at the back there, Edwin? Girls, you guys have issues at the back? Can you kind of chill a little bit, okay? Keep it down a little bit. Okay, so 49. All right, so they get 2y, y prime equals 3x squared. Okay, so y prime. Did we get 3x squared over 2y for y prime? So this is what you're questioning, huh? Wrong one. Okay, so listen up, okay? Let's try and focus on this. So S, you're questioning this move here, right?
Can't see, but yeah.
Okay, which is 1.
Right.
Okay, now why did they do that? The reason why they did that probably is because they get a y squared downstairs. And see, y squared equals x cubed. Did you see that? So if you do this, you get 3y over 2x times x cubed over y squared. And x cubed over y squared equals 1. So that's a pretty sexy move. It's a pretty sexy move. Okay?
They're just trying to use the equation.
Yeah, so then this becomes 1. Okay? And then you go to differentiate 3y over 2x, which is a lot easier than having to differentiate what we had originally, having to differentiate this guy. So, I mean, that's a pretty creative move. Very creative. Okay? And where does this creativity come from?
Human mind.
From the human heart, from the math art. Comes from the heart. Okay? Yeah, so pretty creative move. What's the final answer is 3x over 4y.
How did they get that?
Well, if you follow this path, you want to copy this down?
Well, but I didn't do it that way.
Okay, well, we'll try and go over your method and we'll see if we can come up with this answer, okay? Should be able to come up with this answer.
What you did.
Yeah, but, well, we can massage it to a point and we should come up with the same answer. There is only one answer. You know, we just have to be creative about how we massage the thing. Right? Which was the next problem? 61. 57, okay, let's go do 57. Okay, number 57. Find the points at which the graph of the equation has a vertical, horizontal, tangent line. Okay, nice. 25x squared plus 16y squared plus 200x minus 160y plus 400 equals 0. So the bottom line, the question's asking you, when is this equal to 0? That will give you the horizontal tangent. When is this equal to undefined? And that will give you the vertical tangent. This will give you horizontal. Okay? So these are equations that we'll have to solve once we find dy by dx. You with me? So let's go differentiate. What do you get when you differentiate 25x squared? Cindy, Heather? Sorry? 50x? Yep. And the next one?
For y's, do we?
So it'll be 32y times y prime. And the next one? Stephanie? 200. And the next one? 160 y prime. And the next one? 0. So this is all equal to 0. So if I isolate the y variable, I get y prime 32y minus 160 is equal to minus 50x minus 200. Is that okay so far? Okay. Then y prime is going to be equal to minus 50x minus 200 over 32y minus 160. Okay. And if you set this equal to 0 to do this one here, if you set it equal to 0, then you know that x is going to be equal to 4, negative 4. Well, you take this number and you shove it in here, 4x, and solve for y. Okay? You with me on that? Yes? No? Take x equals 4, shove it in this equation. Okay? And you should get an equation in y, a quadratic equation. Y is x equal to negative 4? Is that what you're asking me? From here. Okay, by setting this equal to 0, the only way that can happen is if the numerator is 0. Right? You with me on this? Okay? And then take x equals negative 4, shove it in the original equation, you get an equation in y, and you solve that. Okay? Now the other one, to do the undefined one, the denominator is going to be 0. So this guy is going to be 0. Which means that 32y equals 160, y is equal to 5. And then you take y equals 5 and you put it wherever you see y in the original equation. And you get an equation in x. And you solve that. Okay, is everybody okay on this? Goosey? Yeah? Karthik? Is everybody okay on this stuff? Yeah? Yeah? Monica? Sajal, ठीक है? Okay. Next one.
Next one is 63. Yeah.
Okay, next one 63.
Okay, 61. Sorry. 61 is just called the trig function.
It says use a graphing utility to sketch the intersecting graphs of the equation and show that they are orthogonal. Remember, two things are, and they tell you what the definition of orthogonal is. Okay, two graphs are orthogonal if at their points of intersection, their tangent lines are perpendicular to each other. So you've got one equation that's x plus y equals 0, the other equation that's x equals sine y. Okay? So is the problem with not being able to put it in the calculator? Is that what the deal is?
No. You just do it with just how you normally do it, right? Y.
Yeah, except in this one here, it's going to be y equals sine inverse of x.
Right.
Is that what you did?
So how do you do the inverse of x?
It's right there. It's right over the sine button, the second button.
Okay.
Okay. So you'll have okay, so you got y equals negative x. So the first one's going to be this guy. The second's going to be sine inverse of x. Okay. And it doesn't tell you what domain to use. So I'm going to go window this guy from 0 to 2 pi.